Section 8.1 is about the law of sines, and our objectives are to use the law of sines to solve triangles, and then find the area of any triangle given the length of two sides and an included angle, and also using the law of sines. So quick review. Before, when we said that we wanted to solve a triangle, that meant determine the measures of all of the sides and all the angles. Find all the side lengths and all the angles. For example, we're going to solve this triangle. This is going to use techniques from chapter 6, so it'll be a good refresher here for us. The first thing I know is that if I have a 90-degree angle and a 37.1 degree angle, this angle up here, angle Z, has got to be its complement, so we can subtract 90 minus 37.1 to get that angle Z. So angle Z is equal to 52.2 degrees. Now I only have one side, but I can use the original angle and tangent to find the side Q, or cosine to find the sine W. So we'll get going with those two things as well. So if we use, say, let's find Q, little q first, that would be opposite over adjacent, so that's tangent. So we know the tangent of 37.1 degrees is equal to little q divided by 6.3, opposite over adjacent. So if I multiply the 6.3 over, 6.3 times the tangent of 37.1 degrees equals little q. So if I check my mode, I am in degrees, so then I can do 6.3 times the tangent of 37.1, and that gives us a 4.765 side length for little q. Now because little q is rounded, it makes sense to find W using this angle with a adjacent over hypotenuse, a cosine, instead of trying to use the Pythagorean theorem. I have those already given to me as they were. If I use my rounded values, we're going to maybe introduce additional error. Okay, so then for the last piece that we need, little w, we said we're going to use the cosine of 37.1 degrees, and it's going to be adjacent 6.3 divided by little w. And I multiply little w to the other side, little w times cosine of 37.1 degrees equals 6.3. This time I need to solve for little w, so I'm going to divide off the cosine of 37.1 degrees, giving us little w equals 6.3 divided by the cosine of 37.1 degrees, which is 7.899. And so this triangle is now solved, now that I know the measure of all the angles and the length of all the sides. Okay, so that was something that we had talked about in chapter 6, and so we're reviewing it here, and we're going to add to it as we look at the law of sines. Okay, so in our first topic, we want to solve oblique triangles. Okay, so these are triangles that are not right triangles. Triangles that are not right triangles are commonly referred to as non-right triangles. And we can solve any non-right triangle. We just need to make sure we know at least one side and just two other things. So that could be angles or side. So we need three things altogether. One of them has to be a side. We can't just know angles, because if the angles are the same size, we could have similar triangles of various sizes and they wouldn't be solvable. But if I have one side and two other things, I'll be able to solve them. So we can solve something that would be a side angle, angle. We could solve something that would be a side, angle, side. We can solve something that would be a technically side, side, side. I forgot side, side, side. And we could solve something that has these in any order, of course. And so oftentimes when these are written, they're written so that the thing in the middle is in between the other two. So this angle is between that side and that angle. So I could rearrange this and put the side I know in the middle. So we could do an angle, side, angle as well. And I think that is all of the possibilities besides side, side, angle. Okay, so these are just a couple of possibilities, but I need to know at least one side and then two other things, whether they're angles or sides. Okay. The law of sines. Let's say we know that we can, now that we know that we can solve oblique triangles. Oblique triangles are triangles that have angles that are larger than 90 degrees in them. We just need to develop a way to do so. So let's start with a generic oblique triangle, and we're going to bisect it with this height line right here that's creating a right triangle. So if I'm talking about angle A, in terms of the right triangle, so ignoring B and little a right now, in terms of the right triangle, I know that the sine of A is h over b, or h is equal to, if I multiply b the other side, b sine A. Okay, sine of b is opposite over hypotenuse, h over A, and so h is equal to a sine b. Therefore, since those are both equal to h, they have to be equal to each other, so therefore b sine A is equal to a sine b. And if we divide the little b and little a over to get them on the same side, rewritten this would be sine of A over A equals sine of B over B. So this is the premise for the law of sines. So the law of sines, you can do this with any of the angles. So you could drop a straight 90-degree angle down from any of these over from this one and make the same kind of relationships between A and C or B and C. And so we find that law of sines says that sine A over A is equal to sine B over B is equal to sine C over C. Now, you can also flip it in the other order and put the little part of the fraction, the side on top and the sign on the bottom, doesn't matter. It just depends on which one you want to find, which one you want to write. So same thing, of course, to write those fractions are equal. If the two fractions are equal, then the reciprocals are certainly equal. Okay, so these hold true for any triangle. It doesn't have to be a right triangle. So all closed three-sided figures, all triangles. Okay, so now we're going to use the law of sines. Again, we just found it in two forms right here. We're going to use that law of sines to solve two types, the angle-angle side and the angle-side-angle first. Okay, so there are two angles known in one side. AAS has, if I draw an AAS, it has angle, angle, side. So I know these two angles and I know that side versus angle, side, angle, where the side I know was in between them. So it is different situation, but they are both two angles and a side. Okay, so let's look at two situations where I know two angles and a side. So starting here, I'm going to draw just a general triangle. I don't know what side is which, but let's start with something that I label A, B, C, and I know that B is 38 degrees and C is 21 degrees and little b is 24 measure. I don't know what the units on the 24 are. Okay, Now, the first thing that we can find is angle A. And so, since I don't have a 90-degree angle, I have to subtract these two, both from 180, because all the angles in the triangle add up to 180. So I'm not subtracting just a single angle from 90 anymore. I don't have a 90 to take away from the 180 to start with. But I can still do 180 minus 38 minus 21 to get our measure for A of 121 degrees. So A is 180 degrees minus 38 degrees minus 21 degrees. So A is 121 degrees. So now I know A's measure. So if I know two angles, I'm able to find the third with just subtraction. Now I want to find the measures of side A and side C. So let's go for side C first, since we already knew the angle for side C. And so we're going to set up a ratio. We're going to do it in this form because the side is what I'm looking for. So we're going to set up the ratio for B. So for B, 24 over sine 38 is equal to little c over sine C, big C. So this is little b over sine of big B, little c over sine of big C. And then if I multiply the sine of 21 over, we'll have 24 over sine of 38 degrees times sine of 21 degrees equals little c. And we can use our calculator to evaluate that. So 24 divided by the sine of 38 times the sine of 21 gives us a little c value of 13.97. Okay? Little c value there of 13.97. So we can write that in here as well. And we can do something very similar to find little a now that I know the angle for A. Note that because this is not a right triangle, we do not have the Pythagorean theorem option to find the third side. It must be found using law of sines. So again, we can start with 24 over sine 38 for the little b over angle, sine of angle B, and then little a over sine of angle A, which we know is 121. Multiply both sides by the sine of 121. Gives us little a. And so I can do sine of 121 times 24 divided by sine of 38. And so I get 33.41 for little a. Again, I don't know the units, but I have now everything that I didn't know. I already had the other three things. Now I have the final three things for all 6 pieces total.